Good morning, everyone, and welcome back to our tutorial series, a comprehensive student guide to data mining. I'm your name, and today we are diving into Module 1.4. Up until now, we've talked about what data mining is and why it's valuable. But in the real world, jumping straight into algorithms without a plan is a recipe for disaster. Today, we are going to build the foundation for every successful data project you will ever work on. We are going to learn about the industry standard blueprint the professional data scientists use to keep their projects on track, the CRISP-DM framework. Let's start by painting a picture of what happens when we don't have a process. Imagine you're a detective. You walk into a room with a million clues scattered everywhere: photos, fingerprints, witness statements. If you just start grabbing at random clues without a theory of the crime, you'll get overwhelmed. You might spend all day chasing a clue that has nothing to do with the actual crime. Data mining is exactly the same. Because it's exploratory, it's easy to fall into what we call analysis paralysis. You might start looking at the data, find a really cool pattern, and spend 3 days visualizing it only to realize that pattern has nothing to do with the question your boss actually asked you to solve. Without a process, we risk losing sight of the real business objective. We also risk discovering data issues far too late. Imagine spending weeks building a complex model, only to find out that the most important column is 80%. So, what's the solution? We need a standard framework. Think of it like building a house. You wouldn't just start nailing boards together, you'd use an architectural blueprint. That blueprint defines the phases: foundation, framing, electrical, plumbing. A data mining framework gives us that same roadmap. It breaks the complex project into defined, manageable phases with specific tasks. This does two powerful things. First, it makes the project reliable. We aren't guessing what comes next, we follow a proven path. Second, and perhaps most importantly, it improves communication. When the business team and the data team share a common language like business understanding or evaluation, they can collaborate much more effectively. The business team knows what to expect from us, and we know what. So, what is this framework we keep talking about? It's called CRISP-DM. This acronym stands for Cross-Industry Standard Process for Data Mining. It's not some new untested theory. It was developed back in the late 1990s by a consortium that included SPSS, NCR, and Daimler Chrysler. They got together to solve the exact problem we just discussed, the chaotic nature of early data projects. Since then, it has become the most widely used data mining methodology in the world. One of the reasons for its longevity is that it is vendor neutral. It doesn't matter if you use Python, R, SAS. Before we look at the diagram, I want to engrave one key idea in your mind. Please remember this for the rest of your career. A data mining project is not just about building models. It is easy to fall in love with the technology, the neural networks, the gradient boosting, the deep learning. But those are just tools. The ultimate goal of any data mining project is to solve a real business problem using data. CRISP-DM enforces this philosophy because it covers the full lifecycle. It forces you to start by understanding the business problem before you even look at a single row of data. And it forces you to keep going until that solution is actually deployed and being used in the real world. Welcome back. So, now we arrive at the heart of the matter, the CRISP-DM lifecycle. Take a good look at this diagram. You'll see 6 phases arranged in a circle with arrows pointing every which way. That circular shape is intentional. The phases are: business understanding, the starting point; data understanding; data preparation; modeling; evaluation; deployment. Notice that it's not a straight line. You don't just do business understanding and then forget about it. The process is iterative. For example, when you get to data understanding, you might realize you don't have the right data, so you have to go back and revisit the business understanding to adjust the Let's zoom in on phase 1, business understanding. This is the phase where you put on your consultant hat. Your goal here is not to think about algorithms or databases. Your goal is to understand the domain. The first key task is to determine business objectives. You need to ask the stakeholder, what problem are we actually trying to solve? The answer might be we want to increase sales, but that's too vague. You need to dig deeper. What kind of sales, to which customers, over what time period? Next, you define business success criteria. How will the business measure success? Is it a 5% reduction in churn? Is it a $1 million increase in revenue? You need a quantifiable target. Then, you assess the situation. What resources do you have? Phase 2 is data understanding. This is where we start collecting our raw materials. It begins with data collection. You go out and get the data identified in the previous phase. Maybe it's from a company database, a data warehouse, or a bunch of Excel files. Once you have it, you need to describe it. How big is this data? Is it 100 rows or 100 million rows? What are the fields? What are the data types? Is the customer ID stored as a number or a string? This is basic housekeeping, but it's critical. Then comes the fun part, data exploration. You start querying the data, looking at summary statistics. You know, as I was preparing this section on the KDD process, I kept thinking steps 1 through 4. That's where most data projects go to die. The cleaning, the integrating, the transforming, it's essential, but it kills momentum. So I want 90 seconds to tell you about a tool that's been a game changer in my workflow. It's called Finot. Think of it as an end-to-end analytics platform that's completely browser-based. You know Power BI and Tableau? Finot is in that family, but with a powerful twist. Here's what makes it different. On a visual canvas, you drag and drop components to build your entire data pipeline. Bring in data from Excel, CSVs, JSON, or connect directly to databases. Finot automatically creates PostgreSQL foreign tables from your files so you can query everything with SQL instantly. Then, right on that same canvas, you apply transformations, run aggregations, and generate beautiful visualizations, bar charts, line graphs, box plots. You never leave the platform. Think of it as Tableau's visualization power combined with the workflow capabilities of a data integration tool all in one place. Everything autosaves, so you never lose work. Whether you're an analyst, a scientist, or just love exploring data, Finot helps you spend less time wrestling with code and more time discovering insights. It's open source. Check the link in the description at github.com/debo/finot to get started today. Alright, back to the tutorial. Thanks. Now we move to phase 3, data preparation. I want to be very honest with you, this is where the real work happens. In the industry, we often say that a data scientist spends 60% to 80% of their time in this phase. It's not glamorous, but it is absolutely necessary. First, we select the data. Just because you collected it doesn't mean you need it all. You might decide to drop columns that are irrelevant or have too many missing values. Then, we clean the data. This means handling those missing values we found earlier. Sometimes you fill them in with an average. Sometimes you delete the rows. Phase 4 is modeling. This is the phase everyone thinks of when they hear data mining. Now that our data is clean and prepared, we can apply algorithms. The first task is to select the appropriate techniques. If you're trying to predict a category like will churn or will not churn, you might use classification algorithms like logistic regression or random forests. If you're trying After modeling, we hit phase 5, evaluation. This is the reality check. Before we show the model to the business stakeholders, we do a thorough technical evaluation. We look at performance metrics like accuracy, precision, recall, or whatever metric aligns with our goal. But we don't stop there. We go back to the business success criteria we defined way back in phase 1. Does this model actually meet those criteria? If the goal was to reduce churn by 5%, does our model have the predictive power to enable that? If not, it might be a great model technically, but a failure in business terms. We also need, if the model passes evaluation, we move to phase 6, deployment. This is where the model finally starts generating value. Deployment can look very different depending on the project. It might be a real-time API like a system that automatically approves or denies credit card transactions in milliseconds. It might be a dashboard that updates every night so marketing managers can see the latest customer segments. Or it could be as simple as a PDF report that goes to the sales team every Monday morning. But deployment is not the end. It's actually the beginning of a new responsibility. Once a model is live in the real world, you have to monitor it. Data patterns change over time, a phenomenon called concept drift. A model that was accurate last year might be terrible this year because customers. So why does all of this matter? Crisp DM transforms data mining from a chaotic, artisanal craft into a disciplined, engineering process. The benefits are immense. Organization, it breaks down an overwhelming project into manageable chunks. Alignment, it ensures that every algorithm we build is tied back to a dollar sign or a business goal. Iteration, it acknowledges that we won't get it right the first time and gives us a structured way to improve. Scalability, by following a standard process, we can repeat our success on other projects. We can hand off a project to another team, and because they know crisp DM, they can pick it up. And to wrap up today's session, I want to leave you with 3 discussion questions. These are great for thinking about how to apply what we've learned. Number 1, imagine you work for a university. How would you apply the 6 phases of crisp DM to a project aimed at predicting student success, for example, identifying students at risk of dropping out before their second year? What would business understanding look like?